Okay, cool. So, yep, I'm recording now. So today we got a couple of things we're gonna talk about for our meeting. I have a brief little presentation I'm going to do about VM detection, or anti-VM techniques used by malware, just some of the things that they do and look for. And then if you're doing an analysis, maybe one thing that you can try using a X64 or X32 debugger plugin. But then first and foremost, for today's talks, we're going to have the club vice president, Odin. He's going to talk about his SRI project. So I will hand it off to Odin.
Just getting my presentation ready.
That's fine.
I think your screen is zoomed in or something.
Yeah, that's on purpose.
Okay. This is research that Odin conducted throughout the entire school year. With the SRI, you can apply and get a $500 grant, both as an undergraduate or as a graduate student. And he worked with Dr. Stroshine, and just this project that he picked out and spent a lot of time working on it, trying different things and getting some good results.
Yep, that pretty much sums it up. This is my project that I did on evading antivirus detection, and my faculty mentor was Dr. Josh Stroshine. So the main questions that I wanted to answer with this project was bypassing so just a little background information. Bypassing antivirus tools are a very important part of gaining a foothold on a target system. Red teams will often need to bypass antivirus tools in the course of gaining a foothold on a system. And let's see. And antivirus tools are, of course, used by these days mostly anyone who uses a computer, from individuals on small home networks to large enterprises. So there really is a need to better understand how antiviruses work and how they're better detecting, and how like what kind of methods that they're using to detect malware, so that we can think of different ways to bypass antivirus tools. So the main research questions that I had is, are current evasion techniques sufficient in bypassing antivirus tools? Current evasion techniques that are known and used by red teams. And then, which methods are antivirus tools primarily using to detect malicious files? And then, which methods are the most successful in bypassing antivirus tools? And then, how can these methods be improved for future research as well? So for this project, an executable was used as basically a loader to deliver shellcode to the target system. And the reason I chose mostly focusing on shellcode is that shellcode is a common method used during exploitation, and also shellcode is commonly used in malware. So for this, and in this case, I chose Meterpreter specifically because Meterpreter payloads are used widely in the security field and are used by red teams. And also, Meterpreter payloads nowadays are known by most antivirus tools, so it kind of serves as a good baseline to test for evasion techniques. And let's see. And so the research was conducted on 6 antivirus tools: Windows Defender, Norton, Bitdefender, Kaspersky, Avira, and Avast. And these were chosen because these were among the most top-rated antivirus tools and the most commonly used by consumers. So then 4 different evasion techniques will be tested and compared for this project. So the 4 methods, which I'll explain in more detail in the future slides, are building a custom loader, building a custom crypter, obfuscating shellcoded memory, and then separation using a DLL loader. And so the effectiveness of these techniques will then be analyzed. So by effectiveness, I'm measuring, is Meterpreter able to connect to the target system? And are we able to execute all of the different commands in Meterpreter? So that's how I'm measuring effectiveness. And so at the end, I'll compare these methods and like show different results of what worked and what didn't work. So the first method I did was building a custom loader. So this was probably the most simple method that I used. So this involved generating Meterpreter shellcode, the reverse TCP Meterpreter shellcode, the stage version. And then, so then I used this to build a custom loader, which uses virtual alloc to load the shellcode into memory. So on the left, we can see the shellcode being generated in MSF Venom. And then on the right, we can see the loader that actually loads the shellcode into memory. So the second method that I used was building a custom crypter. So basically what this is there's a segment for code and a segment for data, and these are actually merged together in one segment. And then so these segments are encrypted during runtime by a file that there's one file that crypts the another file, and then the code and data, they're merged together, and then they're encrypted, and then a stub is added to the program. And then when this program executes, the stub decrypts the section with the code and the data in it, and then this allows the program to execute the shellcode in runtime, but it's able to bypass the signature based scanning and also some heuristic scanning. Although nowadays some heuristic scanners are pretty good at detecting the use of the decryption loop, but it still can evade some heuristic scanners. So for this method, I used the Crypter created by Bill Blunden in the rootkit arsenal. So I took this code and I changed it around a bit to do and then use like my own custom key for like using Zora encryption. And I also found some information from a blog there. And let's see, so this project, it consisted of 2 different files. So on the left, you have the crypter that I used. So a part of it, this is just the function that encrypts the actual, it encrypts the section with the shellcode, and it uses like this key here like a custom key, so it can't really be detected by any signature-based detection. And then on the right is the actual app loader. So this is like the stub section that decrypts the code, and then it can run. So the third method that I use to evade antivirus tools is obfuscating shellcode in memory. And so what I mean by this is you take like a given shellcode, and then you add like additional trivial instructions, like additional assembly instructions to the shellcode that don't change the functionality at all of it. They're just kind of like junk instructions, but it preserves the functionality, so the actual functionality of the shellcode doesn't change. And so to accomplish this, I made use of an open source tool called Obfuscating. This tool is able to insert random instructions which can confuse runtime scanners. So they can still often, this can still often get picked up by behavioral scanners. And so the last method that I used is using a DLL to load the shellcode. So through my research, I came across a blog from Rapid7 explaining that sometimes when you load shellcode from a DLL instead of from the actual program itself, sometimes this can evade antivirus detection because the scanning is sometimes less intensive when scanning DLLs for some reason. The runtime scanning is sometimes less intensive. So I created a loader which used load library to load the shellcode from the DLL, and then this is able to sometimes bypass the runtime scanners, and sometimes this can still be picked up by behavioral scanners, but it depends. Sometimes it's able to evade behavioral scanners as well. So, and this was mostly successful at the time when I tested it on Windows Defender. So a remote session would be launched, but then when certain commands were run, such as the shell command, it would often get picked up by Windows Defender's behavioral scanners. So this is just some of the code that I use. So this is on the left. This is the actual like the base loader, which uses the load library to load the shell code, and then it uses get proc address to find the location of the shellcode and then launch it. And then on the right is the actual what gets compiled into the DLL, which contains the shellcode. So then other attempts and challenges that I ran into. So I also attempted a couple of different evasion methods, but was not successful in getting these to work, and these did not produce conclusive results. So one of the evasion methods that I attempted was doing sandbox evasion. So I mostly looked at Windows Defender for this. So I came across a lot of different bugs that explained like different ways that you can escape out of a sandbox. So in antivirus tools, often they'll use like a sandbox to like to run a program, and then when it's able to run the program and then kind of like figure out different indicators that it could be malicious, and it actually runs the program and analyzes its behavior. So if you can escape from a sandbox, then you can avoid this from happening. So I attempted to a lot of different sandbox evasion methods on Windows Defender, such as attempting to exploit the time deadline, which can sometimes, since antivirus tools are designed for performance, often if you like wait too long to like actually launch the shellcode, this can sometimes like this can this will like the scanner will just uh, quit and not scan the file. So then another thing I did was I attempted to allocate a large amount of memory, which can sometimes throw off sandboxes, and I checked for the presence of a debugger. But Windows Defender appears to be hardened against all these methods when I tested it. And then I also attempted to do some remote process injection attacks. So what this basically means is I would take the shellcode and then inject it into a remote process. But this was not successful in the Windows environment that I was testing it in, and it's quite possible that Windows has mitigations against the particular process injection method that I was using. So here are the results of this test on these 4 different methods. So the original loader, like just loading the shellcode into memory and not making any real attempts to evade antivirus tools, which was detected by all 6 of the antivirus tools, which was expected, since these are supposed to be like the 6 that are able to detect basically the most. And then so encryption, this was detected by a lot of them as well, although was able to evade Bitdefender. And then obfuscation, also most of them were able to detect this one, except Vera was somehow able to evade. It was able to evade Vera, and then the obfuscation and the DLL loader. So I combined the two of these together, and this one was the most successful at evading antivirus tools. So like the only ones it didn't was, so like Defender was partially evaded because so like Defender, as I kind of mentioned before, like it was able to get past the stage where it was able to like have a maintain a remote session on the target host, but then when certain functions were run, then it was able to detect it based on the behavioral detection. And then Norton and Kaspersky, they are using more advanced methods, one of them being like detecting suspicious network activity, and then sonar detection is like more advanced behavioral detection. And then so these were the results in VirusTotal, which when you're on a red team, it's best probably not to upload results to VirusTotal, because when you upload results to VirusTotal, they're shared with the security community and with different antivirus vendors. But for my project, it was okay because the idea was to share this information with the security community. So there also was another screenshot that I forgot to include, and this one had like not the original loader, but like if you went into MSF Venom and then like generated an executable with shellcode in it using MSF Venom, then that was detected by 53 out of the 70 antivirus tools. So, but if you use like the loader from the first example, this goes down to like 29 out of 70, and then the obfuscated loader was like 17 out of 70, and then so what the reason why these numbers are different, so why this is 69 and this is 67, is some antivirus tools seem like to not be like they don't like provide they don't provide that it's malicious, but they're not so I just assume that it's undetected, so that's why I'm saying 17 out of 70. And then I would assume that the fourth example, so the obfuscation plus the DLL loader, probably evaded a few more, but since VirusTotal, like I couldn't upload to like a program consisting of two files, and like like VirusTotal doesn't support that, so I wasn't able to test that on VirusTotal. But the assumption would be that that it was probably able to evade a few more, considering if you look at this, the last table, it was able to evade a lot using that method. So just more about the results. So I already explained like it was able to fully evade 3 out of 6, and then one was partially evaded. And from the results, so basically what we can gather from the results is that, well, for one, quite a few antivirus tools still rely on basic signature detection methods, and then some also rely on basic runtime and heuristic methods that are easily bypassed. But as you can also see, a growing number of antivirus tools are relying on more advanced behavioral techniques, as well as detecting network activity. That's very common among like the more high-end antivirus tools. So then future research in antivirus evasion should focus more on behavioral techniques and then different methods to disguise network activity. And so I plan to continue this research into the summer, maybe to like create some of my own unique antivirus evasion methods. So then just some future things that I want to look at, and some recommendations to the security community of different ways that they could research antivirus tools is one, first of all, to look at different process injection techniques, potentially creating new ones to attempt to evade runtime and behavioral scanners, and looking at evading network detection, and then also looking more into sandbox detection techniques, because I was able to test this on Windows Defender, but I didn't have time to test this on the other antivirus tools that I looked at. So it's possible that some of these the known sandbox evasion techniques are still successful in bypassing some brands of antivirus, but we should also try to look at maybe creating some new sandbox, like more research in how to evade sandboxes, especially the Windows Defender sandbox. So then another way to evade behavioral detection would actually be to modify the shellcode itself, and then and modify the functionality, and this, and with the goal of getting around behavioral scanners. So a tool could even be developed to accomplish this. And of course, writing your own shellcode can also be a very effective method. So then these are all areas that I plan to look into in the future to develop new methods that can lead to successful execution of shellcode on a target system. And then also one more thing is probably looking at EDR tools, would like endpoint detection and response tools would be very a useful new step as well, because these are corporations are and like large enterprises nowadays are probably relying more on EDR tools. So that concludes my presentation. Did anyone have any questions on that?
That's a really interesting presentation, Norton. You know, one of the things I wanted to ask you, which I mean, you just kind of touched on, was the use of like EDR software. At one of my internships, they used something called Carbon Black, which kind of did like a heuristics approach to like kernel level events. And I wonder if, like you said, that would have a noticeable impact on the detections for the shellcode that you're creating.
Yeah, that's certainly something that would be interesting to look at, and I could imagine it would have like probably a pretty like it probably would be able to detect all the methods that I used, I would imagine. But yeah, I think it's definitely somewhere that we should like in the future that more research should be done about that, because I did not come across a lot of research on like how EDR tools like how to evade EDR tools.
It's my knowledge is kind of narrow, but it it is an interesting topic because it's taking that behavioral or dynamic analysis approach. So it's a lot harder to obfuscate or hide that kind of activity unless you're doing things like process hopping or trying to hide like hijack other processes, or just doing so much activity that it's hard to keep track of.
Yeah, absolutely. So, I got a question from Evan. So, in the future, do you plan to investigate how to bypass different antiviruses on a case by case basis, like extremely targeted bypass methods for Defender, Norton, etc.? Yeah, that would be something that I would be interested in doing more. Yeah, definitely. Like, I came across one conference talk that would have pretty detailed methods for like bypassing Norton. So, that would probably be something I'd be interested in doing. I did look at that a little bit for Defender, but yeah, I plan to maybe look at that for other antivirus tools as well.
I wonder about your usage of virtual alloc, if that had any kind of impact on some of the detection.
Yeah, I would think that probably some antivirus tools nowadays are probably able to detect virtual alloc because it's like that type of process injection technique. Because it's and also, do you mean just for like loading the shellcode into memory as well?
Yeah, the loader ones you had.
Mm-hmm. Yeah, but although a lot of the antivirus tools did appear like they were still able to like evade, for they were still able to like they didn't so still a lot of them didn't detect that method. But I also used another method where I didn't use virtual alloc and I just used like pointers to like inject the shellcode into memory. So that was another method that I tried. Yeah, thank you, Tarek. Those both sound like those could be interesting like methods to look into, like bypassing antivirus tools. And thank you, Evan. And then Graham will be, yeah, I did look into the Shikata Ganai encoder, and that seemed to be picked up by a lot of antivirus tools because it seems like nowadays that they're able to detect that type of encoding scheme that's being used. Sometimes though, like if you combine that with different methods, and if you use multiple iterations for Shikata Ganai, that can sometimes help in bypassing more antivirus tools.
Yeah, I didn't mean to recommend to try to use that. I just meant from an analytical standpoint, if people wanted to see how that works. What I've heard and read is that what can be sometimes successful is if people come up with their own original unique encoding schemes, and especially like you said, if you're doing multiple iterations of something, then there probably won't be any heuristics or any detection set up to catch it because it's brand new.
Well, thank you everyone for listening to my presentation, and I'll hand it over to Micah.
Great job, Odin.
Thank you.
Also, a typical antivirus would like wait until your decoding mechanism or algorithm is finished, and then it will still catch your shellcode. And so this is how it works, I guess.
Yeah, that's what I've discovered when looking at some antivirus tools, is that a lot of them nowadays will they have like what's known as runtime detection. So like when the shellcode loads into memory, it can actually like scan the signature of the shellcoded memory. But like the obfuscation technique that I looked at, that's able to change some of the instructions, can get around like it changes the signature of the shell-coded memory, so it's able to get around some of these runtime scanners. But for the behavioral scanners, it's still often able to detect it based on the behavior of the shellcode.
I wonder about inserting just all kinds of random junk instructions and jumping around and that type of thing, which you kind of alluded to already. I think that might be something to help.
Yeah, that's what the third method that I used sort of did, like the tool of fusion. Like it inserted like a lot of junk instructions and like random jump instructions, and basically just changing around the shellcode to make it. But yeah, maybe I could look into that more for like anti-analysis techniques. That could be an interesting thing to look into.
Micah?
Cool. Yeah. Thank you, Odin. So now we'll move on to the second half. I'll share my screen real quick. Cool. Can you all see those slides? See
Yep.
if I can maximize the screen.
We can't see you though.
Yep. I can turn on my video too. There you go. Cool. So yes, kind of is a little like tangentially related to what Odin was talking about towards the later half with the VM detection. What we're going to be going over is just how like if you're to submit something to like hybrid analysis or virus total, I'm probably actually getting ahead of myself in my slides. But a big thing that analysts will do is they, it's part of the dynamic analysis process. You take that malware, you upload it to a scanning site, like, for instance, any.run. And then it's going to upload that to a image machine where it will deploy the malware. And then it's going to have a bunch of things like kernel monitoring, system events, network, monitoring where it's going to try to capture all that static analysis information about like the sample that you've uploaded. Then it's also going to try to get all that behavioral information. And a lot of times, if a malware author, they have mechanisms to detect whether or not something is in, let's say, like an isolated environment, then it's really important that you can identify when that's happening and try to implement measures to bypass those evasions. So it's like if typically you have a malware author that would contact out to like their C2 network, but instead, because it's identified that it's running in a VM or like an emulator or whatever, it's going to contact like a different domain or host or whatever. So you're not actually going to see the behavior that you want to. So just real quick, some of the three things that we're trying to understand here is going to be how the malware authors detect when malware is running in a virtual environment, maybe some of the ways that we could try to harden or reduce the odds of evasion. And then, these are all kind of related, but there's some distinction. Then how to identify anti-VM behavior in order to improve detection. So we'll go on to the next slide. So some of the ways that malware identifies VMs. So, a virtual machine, it's just software that's trying to mimic how, things are interacting at a, hardware level. It's trying to act as if it's real hardware. But when you do that, there's going to be some artifacts that remain, and they're going to indicate that, what's happening is on a virtual machine and not a physical one. So some of those artifacts that we try to keep an eye out for are going to be like specific files, processes, registry keys, services, network device adapters, and so on. Malware authors, they try to take advantage of these design flaws, and they code it so that the malware will, detect like those configuration files, the executables, the registry entries, or any other kind of indicator that would manipulate the original execution flow. So, and then just a couple of labels or technical terms, if you would call them that. It's sometimes referred to as like anti-sandboxing, anti-VM, or just VM evasion or VM detection. Those are some of the common terms that you'll see thrown around. So one of the first methods that they'll do, and we're going to cover briefly a plugin later on. It's a Cpuid Spoofer for the x32 and x64 debugger. But the point here is, so you want to look at the Cpuid instruction, and here, we have an example where it's executed with EX equals 1 as the input, and the return value describes the processor's features. So you'll have the 31st bit of ECX on a physical machine, and that would be equal to 0. And then on a guest VM, it will equal to 1. So when it calls the Cpuid and it tries to get that value, again, if it's a physical machine, it should return a 0 value. And then if it's on a guest VM, it should return 1. And this is just one of those values you can use to identify the environment. So next, another instruction you might do is you're trying to find the hypervisor brand. So again, by calling Cpuid with EX equals 4000000 as input 1, the malware will return the virtualization vendor string into EAX, ECX, and then EDX. And some of the examples you might get for a vendor string, through a Cpuid call, you're gonna get for Microsoft, you'll see something like Microsoft HV or VMware. Other examples, you might see something different for QEMU or I already said hypervisor, or VirtualBox. Those are some common ones. So the next one here is detection methods. So you're going to be checking for MMX Intel instructions, and these are for faster processing of graphical applications. They're not typically supported in virtual machines, just because you're not going to be using those sort of applications, because it requires like the dedicated Intel graphic chips, and usually you're not like trying to emulate that kind of hardware in a virtualized environment. So you can see on the right side, it's disassembly. You can see some of the MMX instructions and what that looks like. And you might have run into some of this before when you were doing a disassembly of executable or something. So another CPU instruction example is looking for the IN instruction. So it's a like VMware magic number. So it's a technique used for detecting a VMware environment. What this does is it creates like a communication lane with the host, and it's through a specific IO port. So if you were to, and I guess it's not really mentioned, I didn't mention it here, but so you can see below, the example is you're moving VMXH, which is like the flag, into EX, and then EDX, you have VX, and then like the port number you want to use. So when you call the IN instruction, you're going to use EAX for VMXH and then the VX port number. And what's going to do is it's going to try to call it at the ring like 3 layer. And if it's in a physical host, typically you just get like an exception and it would bounce back. But then, or no, sorry. Can't remember correctly. I think, no, it was if it's in a virtual environment and brain fart. No, sorry. Yeah, no, it was actually, so if it's a physical environment and it tries to make a contact out using that IN instruction for VMware, it's a physical environment, it'll raise an exception because, that's not an option. If it's in a virtualized environment and you make that call out using the IN instruction, then it should return back with some kind of response, indicating that that communication with the host exists. So using that response, that's one way malware authors are actually, it doesn't even have to be malware authors. They might try to detect whether or not it's in a VMware environment. And I guess I didn't really mention it earlier, but you'll kind of see with the example I'm going to use. A lot of these methods for VM detection, they're not really just limited to malware authors. They're not the only ones trying to do it. There are a lot of times where maybe you're just trying to protect the the IP of your software, intellectual property, and you don't want other people to easily be able to reverse what you're doing or try to get an idea of the behavior. So another method here is we're going to be checking for known MAC addresses. So what you can do here is you're looking at the prefixes of MAC address, which will indicate the network adapter's vendor. There's obviously a couple of ways we can retrieve them, but in many of the examples I saw, they just show using the WMIC for Windows command. And what it'll do is you'll be able to retrieve the prefix. And the list I have here is just kind of a brief list of some of the examples you might see. So like the top 4 are VMware vendor indicators, and then you also have the last one, which is like a virtual box prefix. Obviously there's going to be others, like again for QEMU or what was the other one? QEMU, yeah, well, whatever. We'll just say VMware, VirtualBox, Hypervisor, and QEMU. And then also sometimes, I mean, if you can edit the adapter or driver information, you can try to scrub that and you could replace it with a different identifier, which isn't one of the methods we're actually going to cover today, but that would be a good one. I mean, you can look up any plugin or any script, and there's a whole bunch that'll actually go out and they'll scrub it for you. So here, this is another method. So you're going to be checking for registry keys. So, and I'll go into this, I guess, for the processes and then the drivers slide after this. But when you use VMware or you try to do like the VMware host tools or VirtualBox editions, what that does is, it loads a set of drivers that they've created that make it a little easier to do, like going back the communication with the hosts. Like whenever you try to do file sharing, where you share like a specific folder or network drive or just, a drive on the host with the guest, or, if you're trying to share networking, that's all going to show up here. And, also later for the processes and drivers, but, also in the registry keys. So these are some examples, like you have the local machine software, VMware tools. Generally, just the fact that VMware is even one of the ones on there is a good indication. But then you also have the hardware device map, SCSI identifier, because that's going to identify like if it's like a VMware disk. So then you also have, again, SCSI disk of VMware virtual, and you have root VMC host E, and then you also have virtual device drivers. So these are all things that VMware or separately VirtualBox are going to use just to make that guest experience a little easier, but they just make detecting a lot easier as well. So here we have checking for VM processes. So any of the following may indicate a virtual environment. Malware can retrieve this info multiple ways. Like you have the WMIC, Win API, command prompt, or whichever. Some of the APIs I might do, you have process 32 first, process 32 next, or task list. There's a whole bunch. I mean, you could also even, and it's not mentioned here, and I realize I don't have a slide for it, but another that you might check a similar way is also Windows services, because if you have the VMware tools or VirtualBox editions installed, you're going to have all of those processes among all the services for those processes as well, for when it goes at startup. So that's another location that they'll try to look for any indicators. So here, then we have checking for the existence of VM files. So, like before, you can check using WMIC, Win API, or command prompt, but here we have for VMware and VirtualBox, and these just indicate some of the different drivers that you might see, on those guest environments. So just looking at the top of like VMware, you have VM mouse. So, it's a mouse driver. You have VM tray, VM tools hook, VM mouse, guest lib, VM HGFS, which is host guest file system. And I think you have like VM 3D ver. Those make like the overlay experience easier. Like when you maximize your screen and then the guest system will auto resize. It's passing that information across the comm channel using like the IN instruction. So, it's one of the things that they're going to do. And then, of course, you have the same things again for VirtualBox. for the mouse, cast file system video, errors, or just the VBox tray. There's a lot of stuff, which is why if you ever make like a Cpuid environment, or you're trying to make your own automated systems for doing this, you'll see people advocate for not using the additions or tools because it's a lot easier to just make do without those creature comforts than it is to try and hunt down everything and make sure you don't have any artifacts that are left over. So here we have like detection methods, checking for running services. So here you're identifying, oh yeah, so I guess I did have the services. Identifying whether one of the following processes is running, indicates a virtual environment. So again, detecting it the same ways. Like there you have a services query, but some of the things you're going to see, VM tools, VM host guest file system, mouse, network adapter drivers, so like VMXNet, VMware tools, all that stuff. It's kind of messy and it leaves a lot behind that you want to look for. So here, this is one of the tools that I was going to show you guys. I posted it in the Slack, and I believe I commented on this in the email that I sent out too. But it was a tool that I just came across while browsing some of tools I found in like a malware tools dump. And it's a Cpuid spoofer. So what you do is like when you have x64 or x32 debugger open with your binary, you can use the Cpuid spoofer begin command, and you can see in the windows there it'll let you change or mask the Cpuid values. So you can change it from something like for VMware to like a Intel or whatever ID, and if that's what a piece of malware is using, or software, if that's what they're looking for, then this is how you can bypass that. And then I'll switch my screen share over to that in a minute. But then just to get through all my slides, the last one here. So some other notable tools you might use.
He has a question.
Oh yeah, sure.
Is that a permanent change, or does it need to be done after reboot?
That's a good question. I think it's just within like the scope of that process. I think if you reboot, it's gonna reset.
That's what I would think.
Mm-hmm. Yeah, I mean, I don't know too much, in depth about the process and what it's looking for. Oops, I just noticed that there are a bunch of comments. Sorry, I was just looking at them all real quick. Okay, cool. Yeah, so the Simmons NX MAC checking. Yeah, that's a good one. So, I mean, the thing is though, like with MAC checking, and this was an example I looked at earlier. So if you have like two guests on one host, they said it's likely that those two will have separate, like MAC addresses, but they'll share the same CPU info. So that would be things like cores, processors, the actual like vendor ID, and then whether or not it returns like a physical or virtual value. But I mean, you can use Cpuid spoofer, so you can modify that. And then you can also use a MAC hardware address spoofer. And there's a lot of scripts out there that'll kind of do it for you. That's interesting. So, oh, sorry.
Have you looked at any of there's actually some really cool custom VMX designs that people have built together with custom VMware BIOSes that like completely that like with once you directly allow the VTX and the virtual handles, and you disable side channel, the side channel vulnerability, you can actually get that VM to like literally present itself as a really capable physical box. I've found, because it completely changes the way it addresses like the CPU ID return, and does all kinds of other really cool stuff, such as it masks the hardware information so it appears as a Dell or an HP computer and things like that when it doesn't query against the system BIOS or the EFI.
Yeah, that's another good one too, the UEFI. Yeah, I didn't think about it that way. So that's another one of the many approaches you could take. Cool. And then okay, and then that was Evan's comment that you spoke about for needing a reboot. Cool. Okay, yeah, and then Odin made a couple of comments. So he mentioned a couple of tools you could use. So there's PA Cloak, which is good for figuring out how your sandbox is being detected. And then VBox Cloak, which tries to prevent some of the methods that we just went over. Yeah, so I can pull both those up. I've never seen PA Cloak before, so that one's new to me. But I think I've heard of VBox Cloak, because I think the Cpuid authors have something similar, or maybe it's this one. And for those who don't know, so Cpuid is it's an static dynamic analysis automated environment that you can. Okay, yeah, it's probably VM Cloak. There's so many similar names. Yeah, let me pull that one up too. Yeah, okay, yeah, because hatching. So Cpuid is now hatching. Now they've moved to that, I guess. So the first one that Odin shared, so this is PA Cloak or PA Fish, I guess. So, okay, yeah, it's a tool that will use some of the methods we just went over to detect whether the environment, is isolated. You can look here. Let me just pop that image in a new tab. We'll just do it like that. Is that good enough for everyone?
Yeah.
Cool. Yeah. So here, I guess you can just see some of the things. So, yeah. So it's got like the CPU information. It can see the hypervisor, CPU brand. It's got debugger checking, and it's looking for like CPU timestamps. So that's a good one we didn't go over. The hypervisor bit or brand. And mouse activity, username, file paths, number of processors, cores. Yeah, so I guess if you have like a lot of appliances or VMs that you're running, you're going to try and conserve resources. So it would make sense where you see that they're checking for like the lower disk size usage, and then doesn't really make sense to only have one processor or one core for a system, and then also like less than 1 gig. So that's pretty interesting too. Yeah, and then something else I guess we didn't talk about was hook detection, to see checking those function methods.
You want to tell people what hooking is?
Yeah, so I haven't gone over it recently, so I might butcher it, but when you try to do process hooking, you're going to use other functions like you see here with the shell execute or create process, where you initially begin with executing one process and then you take control of another. Kind of broad.
I think a lot of times hooking is used in reference to just like APIs. if you go and look at a lot of APIs, I think there's an instruction either right before it or right after. It's like move EDI, which is basically a NOP because it doesn't do anything.
Mhm.
And there are different ways to do it, but you can hook functions. And so you go and send it to some other location. And so other things can be done to that. And then it'll eventually return it back to the intended function. But that way people can monitor functions and keep track of things. And for instance, you could monitor memory allocations and, to try to determine potentially malicious memory allocations, many different uses of hooking, and it's pretty widely done.
Mhm.
In our OffSec meeting last week, my co-officers presented kind of like a user land hooking type method where they were able to hook the write function from like libc, and anytime like an application called write, it would go ahead and just pop a weird message out to std out. So that was really interesting. I was less involved with the creation of that content, but yeah, this is cool stuff.
Would it be like this example here where they're using the right price loss memory?
I'm not sure how it would be in Windows. They only
Hmm.
presented the kind of Linux
Oh,
version.
sure.
So yeah, I'd have to do more research on it.
Okay. Yeah, that's neat though. And it just kind of shows, I mean, there's a lot of methods you can use.
In the past, rootkits have done quite a bit with hooking, but we've seen rootkits diminish a lot in prevalence. And that's also one way that they could help to, historically at least, help keep rootkits more hidden, their visibility.
This one's kind of relevant. So using get adapters info method, and what's going to do is it's going to fake adapter name and MAC address values.
Okay.
If you're really motivated, this is one of the things you could do for detection prevention.
I can see Angel and Odin taking notes.
Yeah. Right. Oh, yeah, sure. So that was PA-Fish. And then the other thing that Odin sent us was VBox cloak. So this is a PowerShell script that's going to attempt to hide VBox VMs from malware that may be trying to evade analysis. Maybe zoom in a little. So it deletes registry keys, kills processes, deletes driver files, and deletes or renames VirtualBox files in system32. So I think that and then VM cloak should be pretty similar.
You know, if these weren't like malware investigation tools, they would seem like very aggressive red team tools.
Yeah, actually. Maybe that's a good point. Like, I mean, I can't really think of any good reason why it might happen, but like, I don't know, if you're on somebody's network and you're persisting and you create a VM and you don't necessarily want that new guest to be detected by like a SIM or something, where it's monitoring for like new VMs through like rendering tags or information being sent like between your browser or just through networking. You might try to like hide this, and maybe that could be like the like the red team persisting part, but
Right.
yeah, it's kind of crazy just how thorough some of them can be. I was trying to find like a specific, I guess you'd have to go to the blog post here, but it's just like a Python library that you can install using pip. Yes, I mean, if anyone's interested, you might want to look into these tools then. So VM cloak, VBox cloak. And then you also have PA-fish for detection. And I think I had a couple of maybe not as good basic ones in my slides. On the next one, yeah, other notable. So, and these just pretty much just use the same methods that we talked about. So you have here PyVM detection, which is just another library you can install, and you can look through usage, I think, or was it under? That's right here. Cool. These are just some of the different detection methods. So is Hypervisor, KVM, FreeBSD, VMware, just a whole bunch of things, VM providers. And then the other tool was anti-VM detection. And what this does is so I guess maybe other side of the coin, like the one with that Odin shared VBox cloak, that's after the fact scrubbing a VM. And then there's this one, the anti-VM, which will create a template, before you power it on and you use it. And then I guess it also has another script that you use once it's started inside the guest. Oh, this is interesting. So as a part of the process for double checking, they use PA-fish. It's neat. Yeah, so then I guess the thing that I wanted to share was, if I go back to my slides, I can find where my mouse is. Yeah, so I'll just go back. Yeah, so this one here is Cpuid Spoofer. I can drop a link in the chat if people want to look at it, because I think this is enough thing to look into. I don't know why I'm typing it out. I should just paste it. So that's the Cpuid Spoofer. And you can download this in your VMs if you want. I mean, you don't have to. It's going to be pretty vanilla follow along. You just go here, you go releases. You're going to want to download both for 32-bit and 64. And you do that on your VM. And then you just drop it in their respective folders. So plugins. Then the usage itself is pretty simple. I haven't gotten all the way through my example, but I think even for a live demo, it should be pretty funny what we're going to be using as an example. So let me switch screens.
So do these just work as x64 debug pluggers?
Yep. So they're just plugins directly for the debugger. So
Okay.
Can you all see my new screen now?
See the lockdown browser.
Yeah. So
Are you going to break out of the lockdown browser's VM detection?
yeah. So I was trying to think what's a really good example for something that's not going to like try to escape from my VM.
Absolutely.
And I remembered trying to do this like freshman year because I was like, oh yeah, learning how to use debuggers. I'm gonna try to patch lockdown browser. I haven't succeeded. I mean, I haven't also spent too much time on this just because like I spend like 10 minutes and then I'm like, okay, let's do something new.
Hey, those 10 minutes add up, man. You'll get it one day.
Exactly. So, and it hasn't, I don't know if it works because I didn't get far enough into it to actually do it. But so we've loaded it in, we're at the system breakpoint. If I refer back to the documentation, or actually, sorry, I should stop it and then I should show what happens without the debugger. So if you just try to run lockdown browser in a VM normally, you get all this and then boom. Browser can't be used in virtual machine software such as virtual PC, VMware, or Parallels. So you okay, and then it subsequently closes. So what I thought would be interesting is I would show you guys how to use Cpuid Spoofer, and then we would see if it would work on lockdown browser. So the two commands to think about are right here. So you have Cpuid Spoofer begin, and then spoofer end.
Hey, could you pause your recording?
Yeah, sure.
Yeah. Liability. It's just type thing.
Oh, sure. Yeah. So here we have the two commands, and I don't even know if this works. I don't think it's going to, because like I said, there's more that it can look at than just the Cpuid. But I was pretty sure it was just looking at.
We only see your the web page.
Oh.
Yeah. And I think it's still recording.
It's blinking, so I think it's paused.
Yeah, it's paused. Oh, that's
okay.
weird. I guess it didn't. Maybe I'll just do it this way. That should be fine. Cool. Can you see it now?
No, I just
No.
still see a web page.
You could try resharing again if maybe.
Yeah.
How about now?
No.
Oh.
Oh.
There we go.
Okay, I see. I hit pause share instead of stop recording.
Okay.
Oh.
It's a very confusing button in my
For
defense. Cool. So you guys can see everything now?
Yeah.
Okay,
Yep.
cool. So the thing I was trying to show was advanced usage down here. You have the two commands, spoofer begin, spoofer end. Just run that quick. So it starts, got to go here. And then I think here we go options. And then, I don't know, fake. And you probably want to go out and get like a Intel Cpuid. I should have found this out of time, but my other problem might be that I'm searching this with Bing. Cool. So I guess that's an example of a mask we could use. Oh, cool. Yep. So, and then I guess here we would grab this. Oh, hit the wrong combo. And then you go okay. And then here, I believe we go CPU spoofer begin. And we should see in the log, or maybe not. Then we'll just run it, and then Should see if something happens. Yeah, let's just see it. It's running through everything. So right now we're actually in, I think this is main for Lockdown browser. Just keep going. Oh, but it access violation.
Inaccessible address, it says.
Yeah, it's
I
odd.
wonder if the address you gave was, or it may not have anything to do with that.
Yes, this is why you don't do live demos. Go back to the plugins.
Did you restart it?
Yeah.
Okay.
Oh, and now we have a VC exception. Oops.
This is progress, though. This is progress.
I think it might be the mask that I'm using isn't right. But it closed my Windows Explorer.
Oh,
So find the right button combo. It's Windows R, right?
for the
Sorry,
run key?
Yeah, I'm just gonna have to do it this way.
Yeah, it should be Windows R. Or, no, I was gonna say this other way. If you do Control-Delete Task Manager, then you can run a new task. But
I'm in. Oh, it did that. I'm in the window browser. So if I do that, it just closes the window.
oh, they don't have like a button to like send.
Oh no, they do. You're right.
Gotcha.
I'm having a brain fart.
It's all good, man. You're doing great though.
Oh, thank you.
Sorry, I was a little late. Oh wow. Okay.
Yeah. So I guess that's why you don't do that, because
That's funny. That reminds me of this one time we were actually trying to like load malicious DLLs into this tool called Landesk. I think they renamed it to Avanti. But basically it's like an endpoint manager. And what had happened is when we replaced the DLL and the computer, when we restarted the service, or got the computer to restart the service, it actually started re-imaging the entire machine. So
yeah, it's not fun.
yeah, for sure. It's all right. We found issues other places. We got our kicks. Oh, you could shift right click in like a folder and then open a command prompt, like open PowerShell or something, and then probably just launch Explorer
there you
from
go.
there.
Oh, you can also do it from like Process Explorer.
Oh, it's not giving you the Windows taskbar.
My limited experience, usually I could get it to.
What are you trying to do?
Trying to get Windows Explorer shell back.
Signing in out and signing back in might do it, but that would like go
I suppose that's what we'll have to do.
of the guest VM. Yeah. I guess I don't know if lock would do the same thing, but we'll see.
Type the, oh, I guess you can do this. I have something else you could do.
I don't know if it'll. Yeah.
Yeah. That was just a lock. It wasn't a sign out. So good.
And this is what happens when you
Got
just
it back. Or...
run things.
You can kill it and then run it again.
Oh, I thought it was already. I don't think it's here, but I thought it was already killed, and that's why it's not coming
Well,
back.
technically, you have Explorer open. That's the weird thing. Is like we're in this state of limbo.
Yeah.
Maybe there's a secondary Explorer task that's being suspended. If you open up PowerShell just anywhere,
Oh,
and
sure.
you do task list and then pipe that to find str and then look for like Explorer, you might want to pipe it to like find str. And then you'll do Explorer or something. Yeah.
Oh, there it is.
It's just one process.
Oh, I think that's just the window, though.
Yeah, that's just that window. What? Okay, maybe it's not. You can do task kill on
Yeah, you can do
5752.
task mode. Task kill /IM.
It would just put the PID, I would think.
Yeah, it should take PID by default, but
Oh,
you can
yeah,
do
duh.
/IM to specify like the base image name.
Oops.
Ah, okay, maybe we need to switch. Oh, thank you, Tarek. It needs a PID switch for PID. That's garbage.
Oops. Okay, maybe now if we.
Yep.
Nope.
Dang. All right. Respond to Spites back.
Try to
There's-
go and type, get the taskbar.
Sure. Can you just do? Is it that one?
I just meant the regular Control Alt Delete taskbar.
Oh, wait.
How did you kill Explorer and it didn't reload?
It's a good question.
Because usually it should reload and give you like a new desktop with a taskbar and everything.
Yeah. I
Try
was-
doing
Oh, sorry.
Task Manager. I'm sorry, that's what I meant to say.
Yeah, task MGR, I guess.
There you go. Here I have
At
another.
this point,
idea.
probably just reboot, honestly. Reboot the guest VM. I don't know if you can, but
Oh, okay.
has been
Try
disabled.
Control Alt Delete.
Well, I tried that. If I go.
That was only bringing
Oh.
up the lock and change a password.
Sure.
Oh man, that's so weird.
Do you have Process Explorer in there?
Oh, that's a good.
Or Process Hacker?
I do, because Process Hacker you can just do run from there, can't you? Although not that really need it at this point, I guess. Where next utilities?
Try hitting. Go hit the hacker button up at top. hit run. Just type explorer.exe and see if that does anything, even though you've tried to open it. Oh, just the same thing.
Oops.
You just may need to restart.
Yeah, maybe if I just
I wonder what happened. We should check the event logs like at a later time. I don't know if like other people are like rushing or anything, but I wonder what Respondus did to bone the system that much.
I am stuck.
You can't do file exit.
Oh. Yeah, cool. I wasn't sure I could reach it. You should just
Try
be able to
the-
go.
Oh, that's weird. Didn't we kill 5752?
I thought we did.
That's so weird. Oh, maybe because we didn't force it, but
There you go.
Try to force it.
Sweet.
Right, so open it back up again.
I hear guns firing.
I think that's my roommate playing a video game. I'll mute my mic. Sorry.
I just think it's funny.
Drag and drop. If I mean, maybe I could be a little more. Originally, I was also going to try and see if I could patch the detection, for VMware. Like if you go here and then you say search for all modules, and then you can go
String or pattern, either one.
Yeah, and I did this before. This is one of the things I was trying to do. I was trying to see if I could find the call for IN using VMXH. And this will take a hot minute, but excuse me. When it finishes, you will be able to see, you can see all the VM strings, and it kind of helps to like narrow down which functions are doing the VM checking without having to like debug and step through it. I also had it open in IDA as well. If you go.
Virus and threat protection is off.
Yeah, but here it doesn't show anything. And I think that's because I didn't load any of the DLLs with it. Because I think the stuff that does actual like VM detection for this is in this DLL, or it could be in this one, the libcef, just based off of some of the brief stuff I was able to do.
Is there like some type of tool we could use for those DLLs to just like see what functions they have created in them? Like maybe like PE Studio. I don't know if PE Studio would do that.
Well, typically, I mean, you could just do an analysis with resources, I believe. Maybe I can get it to work if I use Ghidra.
Gotcha.
I don't know if anyone's actually like interested in this. So, I mean, if anyone has anywhere to be, you're more than welcome to continue on with your day. But if you'd like to see some weird stuff, you're welcome to stay.
What are you looking for again? I sorry, I had to look away for a second. I heard
Okay.
something about a DLL.
Yeah, so I believe the functions that are used for the actual VM checking are in a DLL file and not in the executable itself.
And you could always open the DLL inside Dependency Walker. That would show all the DLLs.
Okay.
There are other ways too, of course.
Oh, yeah, I didn't think about that. So if we go back here though, I can just narrow it down here. It's kind of the same thing because I mean this does all the modules that have been loaded, but you can see originally I was going to go, I think it was VMHX, but you can see there's nothing there. But if you just do VM, you can
Right, you get
search.
stuff from the libcef. That's like Windows,
Yeah, so
VMnet, virtual webcam.
yeah, so you're seeing the same thing. And yeah, VMnet would, of course, be for the network adapters, which is why I was thinking that the CPUID method wouldn't work because you can see it's looking for VMnet, which means it's probably looking for like the drivers for the network adapter, or it's like doing get adapter info and looking for a VMnet pattern. But then I never saw the string that was referenced to say this cannot be run in a VM.
Gotcha. I don't know if that would be like in maybe one of the libraries that doesn't get loaded until maybe after the check or something. I'm not sure how that would work. But that, or maybe they're doing like some JavaScript malware author advice and just taking an array of characters and putting it together throughout their code. That'd be funny, but probably not.
You would hope that at least that they'd be aware of some of these basic techniques and then try to mitigate against them. So it's probably a good thing that you're not finding it easily.
Yeah.
You would hope, right? There was one time I was messing with Lockdown Browser and I found out, I think they patched out like half of this quote unquote feature, but I found out you could have like a Windows Media playlist, any type of like thing that did an overlay onto your monitor, and that would still go through the Respondus Lockdown Browser. So you could essentially make a fake playlist and like scroll through your songs during some type of exam or something like that. Thought that was really funny. I say halfway patched out because I checked like a month ago and we were joking about running Respondus or something because you can't skip the songs anymore. You can only see the current track of what's playing and pause and play it. I thought that was really funny.
So do you know the name of the function you're looking for?
I do not. So I'm just waiting for it to finish loading. Oh, and it finished. Oops. Yeah, I don't know which one. I assumed if I just jumped to the entry, I would find it in here. Yeah, I'm not terribly sure which one it is.
So the assembly instructions that you were talking about in your slides, can't you look for one of them here? Like search for instruction and try to find them?
Yes, that's a good idea. That would be one of the steps I didn't.
I think that was the pattern. You did the string,
Oh.
so
Yeah, I mean, I did the pattern per se, like just searching for VM HX, which if it
isn't
was
pattern assembly instructions.
No, this is like this is a
Opcodes.
string. Try to find opcodes or like bytes.
Yeah, the go to hex. That's string.
I would have to go
Go
here.
up. Go maybe put your mouse higher up.
Oh, sure.
Oh, huh. It's still a string, I guess. So maybe
just-
not there.
I mean, if it was, I mean, a string anyway, it would just, it'd still show up under the resource or references search.
Let me look at something here.
If I search for a IN, the bytes or hex for IN instruction, that should, like the others were saying. Oops.
IN something. You need to have a INAO.
Oops.
So there are different variations. How are you doing the IN? How are they doing it? Because they have
in-
E4, E5, EC, ED.
Yeah, so in the notes that I had, they did IN EAX DX, which should be a ED for the opcode. So if I were to just go off of that,
And IDA should be able to let you search for the opcodes too if you can't do it in here. See if that gives you anything. Maybe too much.
Yep.
Oh, quite a lot. People can leave if they need to.
Oh, it's right there. I think I must have done something wrong.
What are you wanting to do now? Just map it out?
No, well, I don't think I found it because this is just showing up as a jump instruction. But what should have came up
Is it
was
only-
the,
Is it only 1 byte, the instruction?
yeah. Here, I'll search for it here.
That's a
so you
bummer.
guys-
Try to look for more. 1 byte is not going to help that much because you probably find a lot of there.
mhm. Oh, whoop. Oh, yeah, well, like right here. It should be something like that. That doesn't help though.
Let's go to, do you have your Ida Pro?
Yeah, I do. Or well, I have the free
I think
version.
the free would probably work. Let's move it to a different location.
Can't you search for the string, that error that you got from lockdown browser? Like you cannot use VM or something like that. If you find where this string is coming from, then you can trace it.
Well, that was my thought process too, but then it should have showed up when I did the VM search. Oops, wrong button. But didn't. Maybe. Yeah, like, so I don't see anything for,
What is the second string from the top? Detour detected, disabled, parallel, or maybe something else. Yeah.
not sure. Well, it's under NTDLL. So I don't believe that would be specific to,
No, it shouldn't be.
I mean, you just have right here, and this is in lockdown browser. There's a reference to parallel.
What about VMware?
For that, we did, and the only thing that pops up would be under the libsef DLL for virtual. Oops, webcam. Just go here, and I mean it's kind of confusing to look at.
Do you think they're using fragmentation to fragment the string? Like they're printing, it's not a whole string, it's fragmented.
They could be.
Sneaky way to do it if they did that.
Yes, I think something else is going on too, because if you just like hit run and you just let it go, it crashes and we're getting this exception here. Although it is just loading, so maybe it's something else.
Do you get this exception every time you load it?
Yeah, through the debugger. Normally it would have tried to open the Chrome process, to get to the page, and then it would have dumped the exception, for detecting that it's in a VM.
I wonder if it has is debugger present or anything like that to check.
What's on the stack? Like ESP plus 54? Is this a plus or minus?
um, kind of hard to see. Interesting though, under yeah, I think it has to be in libsaf. Yeah, it's definitely hung up. I mean, this was supposed to be a interesting example, but it wasn't really the best one. Just because I think it was looking for other indicators.
Did you try looking for the strings inside IDA?
Nope, not yet.
I'm probably going to be the exact same thing.
I never did think to look at that, see if it was packed. Would make sense. I'll just let that run.
Did you do IDA Pro in your reverse engineering class, Angel?
No, I think Angel is taking the Linux one, not Windows based.
What was that?
I was just asking if you did the reverse engineering course, if they taught you IDA Pro.
Yeah, we did it. We did just a little IDA Pro. It wasn't much at all. I think I got more IDA Pro experience from Pentester Academy courses.
So go to view, and then subviews at the top.
Oh yeah, search for the strings. I forgot why I had it open.
You should go do quick filter. VMH and the resources.
Yeah.
Well, I don't think that's what you're looking for.
That sounds suspect.
Undetected. Sounds cool.
Oh, yeah, right here. I think.
Yeah, that might be one of the checks they do.
Because I think this is one of the registry keys that we went over.
Oh, interesting.
Because it's the HKLM, OS version root, OS version key, maybe.
You could do a cross-reference on that and see how it's used, what leads up to it.
Yeah, do you know like specifically if any of your registry keys were, checking if they were D words? Because 0 might be an argument that it's checking against.
Let me minimize this real quick. Going back to my slides to. Oops. So. The one that it was doing was maybe just like a survey, like gathering machine information, not necessarily for it being a VM. But it's still weird that, I mean, that's, I would think it's in one of the DLLs, but that should have been,
You think the return type for all those DLLs are just like bool, and we can somehow like write some type of plugin to just have all of those functions return true
Mhm.
or false or whatever?
I mean, maybe.
Maybe.
Hey, I have to leave you guys, but I'll see you guys next week.
Okay, sure.
See you, dude.
That's
Do some
sus.
stuff. Yeah. Do yet more stuff.
Oh, that failed. It's got to be in here somewhere. Here's a disable task manager. or the reference to it. I'm trying to figure out how to get to the function.
Disable task manager. Yeah. I wonder if that's just checking for like base image file name or something.
Probably.
So you said you're trying to get to the function of disable task manager?
I was trying to see if I could get to the function, and then I was just going to try patching it and see if that would work.
Okay.
Oh yeah, like here, so you can see it's looking for stuff. So it's looking for WhatsApp as screen recorder, dictionary, Google Hangouts.
Oh wow. Yeah.
So I'd have to play with this more, but my assumption would have been that there'd be some structure here for like labeled VM or something. Maybe that would be the word to search for. Bypass detected. Yeah, I guess I'll just call it there for tonight.
All right. Well, good
Yeah.
job, dude. Like that was really cool stuff.
I'm glad that you guys find it interesting.
For sure.
I think next presentation for the club, Odin might go more in depth about his SRI research. I don't know if Tarek, if you're still here, but if you wanted to present what you've done as well at that time, I think everybody would be interested. Otherwise, I think Brizendine, he'd asked that I do something on radar. I don't know if you guys would find that interesting too.
Yeah, sure.
Okay. So that might be what we do 2 weeks from now then. And I thought about maybe wrapping in the Mac OS or Mako file structure with radar. but I feel like that might be too much for people when, the point's just to show radar as a tool. So I think maybe we'll focus on that then. And then just to quickly go over it, I think we only have 2 more meetings left, because our next meeting's the 13th and then the 27th. So that'll be it for our club this year.
All right. Well, cool. Take care, everybody.
Cool. Yeah. See you guys.
Bye.
Have fun.
Yeah, take care, guys.
Thanks for coming.
Thanks for coming, everyone.